Hi, we're reviewing for tomorrow's test. Let's do these problems together, you guys. Let's see. Balance this reaction first, and then we can answer a question about it. Let's see, we need 3 carbons there, 4 hydrogens. We've got 6 plus 4 is 10, so 5 oxygens, like so. This question says how many grams of carbon dioxide are produced from 50 liters of oxygen. So start with 50 liters. And you want to get to moles first. So 22.4 liters in 1 mole. We're going from oxygen, right here there's 5 of them, to carbon dioxide, and there are 3 of those. We're going to grams, so we need the molar mass of carbon dioxide, which is 44. When you solve, take 50 times 3 times 44 divided by 22.4 divided by 5. You get about 58.93 grams of carbon dioxide. Same balance reaction, we're going to answer a different question. How many molecules of H2O are produced from 150 grams of C3H8? 150 grams C3H8. Molar mass of C3H8 is 12 times 3 plus 8, 44. Mole ratio from C3H8, which is a 1, to H2O, which is a 4. And you want to figure out how many molecules it would be, so 6.02 times 10 to the 23rd here. 1 mole on bottom. When you plug it in, it is 150 times 4 times 6.02 times 10 to the 23rd divided by 44. And I got 8.21 times 10 to the 24th. And that would be molecules of H2O. Problem 2, new reaction. It says 10 grams of each reactant are used. How many grams of NH3 are produced? 10 of this, 10 of that. One of them runs out first. How much ammonia do you make? So 2 numbers means do the math twice. 10 grams H2, 10 grams NH3, or sorry, 10 grams N2. Let's say the molar mass of hydrogen is 2 grams. Takes 3 hydrogens to make 2 ammonias, and 1 ammonia is 17 grams. For nitrogen, it's 28 grams per mole, and there's 1 of those for every 2 ammonias, and ammonia is 17 grams per mole still. Smallest number here is your answer. So to find that, take 10 times 3 times 17 divided by 2 divided by 3. 10 times 2, I screwed that up. 10 to 17 to 3. And that's 56.6. And for ammonia, or for nitrogen, you take 10 times 2 times 17 divided by 28 and gets 12.14. So your amount produced is 12.14. It's also called the theoretical yield. This question didn't ask, but the one that limits it is N2. Runs out first. Let's see, magnesium is added to hydrogen sulfate to produce magnesium sulfate and hydrogen gas. That's some other numbers. We need a balance reaction first. So magnesium is added to hydrogen sulfate, which is H2SO4, to produce magnesium sulfate plus 2 and minus 2, so they cancel out, and hydrogen gas. 2, 2, 1, 1. Everything is balanced, so we're starting with 25 grams of magnesium. Only one number, so just do this once. 25 grams of magnesium. Molar mass of magnesium is 24.3. And we know it's 1 to 1. 1 mole of magnesium gives us, says how many grams of hydrogen are produced. So 1 mole of hydrogen. Molar mass of hydrogen is 2. So take 25 times 2 divided by 24.3, and you get 2.06, we'll call it, grams of hydrogen produced. Another one where you need to write the balanced reaction. It says 50 grams of aluminum nitrate react with 75 grams of potassium sulfate. How much KNO3 is produced? Okay, it's a little open-ended. Aluminum nitrate, AlNO3, just going to crisscross it. 75 grams of potassium sulfate, that's K2SO4, and you would make aluminum sulfate, which is Al2SO4, 3, and potassium nitrate. When you balance this, I guess things get interesting. Put a 3 here, 6 there, okay, 6 NO3 is a 2 here. So there's the full balance reaction. Now I said that 50 grams of aluminum nitrate react with 75 grams of potassium sulfate. You gotta figure out which one runs out first, and the smallest number would be the amount that's produced. So, aluminum nitrate is 27 plus 14 times 3 plus 16 times 9. 213. And mole ratio for that aluminum nitrate is 2 aluminum nitrates give us, we're going to KNO3, 6 KNO3. And the molar mass of KNO3 is 39.1 plus 14 plus 16 times 3. 101.1. That'll be the same down here. K2SO4 is 39.1 times 2 plus S is 32 plus 16 times 4 for oxygen. 174.2. And let's see, it takes 3 K2SO4s to make 6 KNO3s. And when you solve these problems, the smaller number is going to be the one that you want. So 50 times 6 times 101.1 divided by 213 divided by 2. This one's 71.2. Next one is 70 times 6 times 101.1 divided by 174.2 divided by 3. 81.25. So your amount left over, or I'm sorry, the amount that you made is 71.1. That answers that question how much is produced. This is your limiting reactant, and this is your excess reactant, which is great because the next question says how much excess is left over. So to solve that problem, you can do it more than one way. I'll do it this repeater's way, I guess. Take 81.25 minus 71.2. And you get 10.05. And this would be grams of KNO3. And convert that to the excess reactant. So KNO3 we know is 101.1 grams in 1 mole. Mole ratio, KNO3 is 6 of them. I'm going to convert it to K2SO4, which is a 3. And the molar mass of K2SO4 is 174.2 grams. So 10.05 times 3 times 174.2 divided by 101.1 divided by 6. I got 8.65 grams left over of K2SO4. Finally, If you really make 18.7 grams of KNO3, what's your percent yield? Let's see, 18.7 grams, not a lot, I guess. Divided by what you should have made, which is 71.2. You get about 26.2% yield. Have fun studying. Bye!